we have successfully completed 4 days of proceedings on the emerging technologies on renewable energies resources in India and abroad. We would like to appreciate the active participation of every faculty member registered to this program across the country. We would like to continue this FDP to the 5th day, designed to have 2 sessions. First session, speaker, a distinguished Sri N. Venkata Reddy Garu. Venkata Reddy Garu currently working as CEO of Vihan Electrix, Hyderabad, India. A distinguished, young, energetic entrepreneur, a successful entrepreneur of our day. This is the time to introduce Dr. Reddy and welcome him to take up the session on advanced renewable energy systems of the latest era. Now, myself, I would like to introduce Dr. Reddy. Hope he has joined the meeting. Thank you, sir. So, Sri N. Venkata Reddy has come to MBA and received his Master of Science in United Kingdoms. He is the founder, CEO of Vihan Electrix, before it is called as Tech Team Solutions. He is having 9 years of successful entrepreneur and founder of TechBot, a training, innovative product development firm. He engaged and motivate students through seminars, capacity building programs, entrepreneurship programs, academic projects, technical workshops in all the technical institutions like engineering and polytechnic colleges. He has established around 250 tinkering various schools of Andhra Pradesh and ventured into electric vehicles with the and contribution towards the society as far as climate changes is concerned. He has moved with the climate and he has inculcated and something has to contribute towards the society. He has ventured into green energy systems, with which initiated electric name Vihan Electrix, headquarters at Visakhapatnam. I'd like to tell about his academic awards throughout his career. He's a great passion towards the advanced technologies. Awarded many certificates from and IITs while training robotic competitions. He's a good speaker and young and energetic, and he is a well knowledgeable person 4.0 technologies. He has been of 500 plus students in various levels in Andhra. he is recognized by he is recognized Radio City icon. He's the icon of like, and he's a member of APSSDC, and he had 20 with the industries, with which I request Dr. Reddy deliver the session. Thank you, sir. Thank you very much.
Thank you so much, sir. It was great pleasure to be on this platform. I would like to thank all the participants, time, and all the team behind who are conducting this program. It was a great pleasure, and at the same time, I'm looking forward for a lot of new kind of solutions that are required for the present day world. So the topic that we are talking about is something which is present, and most of the countries even now they talk about the climate change, which is one of the part where renewable energy comes into the picture. So today I'll be more happy to take some insights and share my views. And on
Sure.
top of
So,
it,
I will stop sharing, sir. You can share your screen, sir.
yes, sir. Just a second, sir. Yeah, I'm sharing it. Sir, is it visible?
Yeah, sir. Your screen is shared and PPT is visible. You can put it in a.
Yes, sir. Okay.
Okay, sir. Thank you. Proceed, sir.
Thank you. Yeah. So actually, when we are talking about the present day topic, and the first question when this kind of topic is, we should understand what is the importance of and need more about this particular topic in, because we have utilized all the general resources and we have the next level of generation or the next generation has a hard time to talk about energy and what different kinds of solutions that are available, and on we'll see what out or we can suggest for the next generation, or we can support in building those kind of solutions. So the first thing on particular platform that I would talk about is what is the purpose of this energy? Why do we need this energy, or why do we talk about this renewable energy nowadays? Because every gadget or every device that is there with us right now is completely based upon using. So when it comes to device from charger, mobile charger, to a machinery they're using, everything needs electricity. And on top of it, nowadays using from morning till evening, like it is a 24-hour cycle, because the lights are on, the machineries are running, the industries are running, like 24 by 7, 365 days energy that is being consumed throughout our planet. And on top of it, we have got something like the emissions that are generating while utilizing, at the same time while generating these energies. So this is I think very recently we have seen, like last 6 months or 8 months, we see a lot of climatic change in different locations across the planet. And particularly what happens is we should think about these energy requirements, or the replacement of the non to rent, and wherever whichever the space that we have, important topic and the need of the hour that we are talking about. And everyone knows the world is towards this sustainable development goals, and most of the business people, entrepreneurs, governments are all talking about towards the sustainable development goals. Even the renewable energy, this is the number 7 topic, affordable and clean energy. Either resource we may having any global or reduce the global emissions while utilizing these energy levels and all. So more onto this sustainable development goals, with which having said that, like renew on different scales, what is what is the present and what is the future, and how this is going to be. We are going to talk about that. So the biggest challenge when people talk about this energy demand, I would like to put them into the notice that without having noticing that AI everywhere now, we are talking about artificial intelligence. You talk about chat gpt, llms, everyone building different solutions, but the back end, there is a biggest challenge across all these solutions of AI, which needs lot of training, lot of data, lot of support system required to run an AI solution. So in that solution, now USA, the United States of America, where a lot of this data centers have been placed, and data centers have been created, running short of power, and they are consuming the maximum power from the generated from oceans, from the nuclear plants, from different energy sources. This is one big challenge that we have. For example, years to 10 years, when we talk about AI and data centers need energy. This is one particular aspect that we need to look on in order to. I think recently the Los Angeles fire also came out of this, because a lot of water is being consumed for the data centers, for their power generations, and for the storage and others. In all these, this is one demand that is there for the next generation. What happens if everyone start using electric vehicles? Though people, it is good for climatic conditions. Just for a second, I would like to close certain notifications. Yeah. So when it comes to vehicles, when everyone start utilizing electric vehicles, three-wheelers, two-wheelers, and four-wheelers, I think Tesla, they have been expanding their charging stations. And if everyone start using Tesla EVs across India, see, we crores of population. Now hardly it is like percent the utilization, or the consumption of the electric vehicle increase to 30%, 40%, or 50%, then we need. The challenge is, once if this comes out of the place, distribution is the biggest challenge. So I am just on a few important resources that are required, where energy takes on a higher scale. And one, which is an communication. See, earlier it was like just and used to send letters and something like that, but now communication has been the top notch. So I think most of you know about WhatsApp, Facebook. One day they they just went run out of for half an hour to 1 hour, and the whole evening everyone was trying, and they were trying to communicate. And now communication itself has got across the globe, satellite, and all the communication stations requires an uninterrupted power supply. So in coming days, there is a huge requirement of this energy, and we are extending of this energy. Everyone knows this, very common. And two problems that I'm making into notice, where the new kind of or smart solutions, or on a long run, we have to very uninterrupted things, because without a mobile phone for 1 hour or 45 minutes, or take half day, I think world goes into a panic situation. And that is how we have to make sure that all our energy resources has to be 100% effective. So in taking these three as a major problems, and in order to give the solutions, though we have got other alternatives, I would like to propose these are the general renewable sources that we commonly talk about: solar energy, wind energy, hydro, biomass, geothermal, tidal, and the present world talking about hydrogen. So when we are talking about these different directions, or different concepts or technologies that are available for renewable resources, there are challenges also. And what are the new solutions, or the smart solutions that are coming out in the present world is. So I'll be talking about each and every particular technology here, like what happens in solar, or what is happening in the wind energy industry, or how we are generating this hydropower with different concepts. So we'll be talking about and every stuff. And I would like to bring to your notice that each and every solution are different options, but I want to take the major important applications and utilize them in the longer run. So coming to solar energy, as everyone knows, and now I think 2 to government of India was very focusing on the solar energy in Gujarat and other places. They are massive solar panels, and this panel based units, and most of the airports like areas, they were utilizing this solar energy for their regular usage. But the big, when we talk about solar energy, is all these PV cells, when installing, either it occupies a space, and at the same time there is a lot of cleaning process that has to be done. So now the smart solutions that have come up with lots of companies and a lot of people outside the, instead of we using this high hardcore, like heavy system, uh, some examples that I can give you, these kind of solar systems are useful in most of the areas. And when it comes to this, I have one link which will help us to understand. So let me show you this. I hope the screen, and here you can see that the people who are the new kind of art of solar panel, where it is, and it can be placed at any place. So now you can see on this, they are putting it on walls, and the same photovoltaic cell. Those are much flexible than the traditional that we are using, and you can stick it to any place, and you can generate energy from any point, and it has got more flexibility in cleaning process as well. So if you can observe that, there is one company who has designed the solar panels with the flexibility, and now I think Elon Musk has also come up with some other panel which looks like a glass. Those glasses can be used like window glasses and all, and see how simple to fix. Earlier it used to take a tremendous process, like you have to carry heavy things, you have to go with mechanical setup, and you can see on the rooftop how these flexibility is there. Like country can these kind of solar panels coming out and sticking off this. So it's a company called Helisol by Heliatech. If you see that OPV, there's next. So even the wind turbine, of course we'll talk about hybrid solutions also. But before that, you can just go through an understanding of individual smart that are coming out. You might ask, like, what is the wattage, what is the panel, or what is the cost and all. So that is all the depends upon the application, the place where we are going to utilize it, that we have to look at. So they are using some organic material over here. So you can do some research on this, and you can understand that how can these panels can be flexible in our country, where we have massive home locations. And if you can understand, see, the simple wall has been made it like a solar panel wall right now, and it doesn't take too much of time for them to install it. Okay, so this is how the solar panel, or the flexible solar panel that have come out. One second. Yeah. So when compared to a regular format of solar energy that we take, or giga units, or megawatts that we pull out, so these are the different kinds of solar energy systems that we have. And the example that you have seen is the smart solution that they have come out, making it easy, and you can to any place. On the other side, Elon Musk has come out with another solar panel, which you can search it on Google, saying that solar panel which looks like a glass. And the second biggest thing where most of the hilly areas talk about is the wind energy. Though it might be little costly, or it can be done only certain areas, I'll be showing you the new solutions, or the innovative ideas that have come out in the wind energy. So generally wind energy, as everyone knows, like whenever there is a huge wind that is flowing, there is a wind turbine that is going to rotate. When it rotates, we generates the energy, and we are going to store it and use it. At one point of time, Google, as a company, they have utilized these wind energies turbines to, if you want the rain to come onto that location, they're going to use it, or just run these wind turbines and push the clouds to another side also. So that is one technology that they have breakthrough. And here, when it comes to wind energy, the different types of wind farms that we have got onshore, which is on the land based, offshore, which has been done on water bodies and the distributed. It's like a small turbines that we have got. But coming to the wind energy, the biggest challenge is like, the establishment, the installation, math that has to be done. And it is not so easy and simple to install a wind turbine at whichever the locations that you want. For example, in India and Andhra Pradesh, you have got a certain area called Anant, all hilly areas, and they set up a lot of wind turbines. And if you see our Tirupati, which is a famous place for pilgrims, there you have got a lot of wind turbines where that runs on this particular wind energy as well. But the challenge here is the wind blades, the establishment, the outcome of this energy is huge. And they have come up something, wind trees. So when I said wind trees, it is earlier the solar panel that we are talking about. It's like a leaf. The branch is going to be there with the metal setup, and on the edges you used to have leaves. But here, when we talk about wind trees, so you can see this. This is a real model that they have created. And if you see the tree shape and the wind turbine, the biggest challenge when it comes to technicality is more not about the tree, but the model that are there and structures that they use, because wind flows at a lower, hardly like 10 meters per hour or something like that. When it comes to that line, see the radiation that it is generating. So that will generate a very small amount of currents. Though the voltage is low, I think the tree that can understand is very small. So here is the 30 feet, and you're testing that they are. And something simple, you can do it in a public domain. I think you can see it over here. So wind is at 5 meters per hour. So it's like 5 to 10 meters per hour. It is enough for it to function. And R&D, the reason that they have done is on these wind turbines, different models also. These kind of trees will help out new kind of solution where you can solar on this wind. So this different options in wind energy. I want one more turbine. This is for domestic kind of thing. So if you can see this one, this is a structure. Of course, real structure that design when it comes to this can be used household or very can be installed. Recently, one has done some, in this wind, they are generating water. So they are generated from air. That's a different concept, of course. Here you can see different turbines. And apart from this wind and solar, there is an important aspect. So we have high concepts that will. There is some hydro comes to the power. We get in parameters, large dam in construct, and the different stages of these kind of where they generate the move water. Comes to the water, you should have huge preferences or very different. So falls with, and it starts getting the winter. Then it rotates and generates the power. But on the other hand, are at a speed. So solar and has more flexibility and easy for a gen person. But when it comes to hydro movements or agents that they use, these options. So when it comes to power, the most common stuff that we own is store the water in and the dam. Whenever the dam is full and there is the water and flow of water or something like that from the reservoir, they are going to generate some out of it. Otherwise, there is a small risk where they are going to have a natural flavor. So today, when we talk about the new solutions, I would like to address these kind of river flow, a natural flow which is happening in the river. I think we can do something that direction, because when it comes to dams or water and very big place, it might be easy to innovate or create something. But the river, because it's been a natural flow, we can have some designs anyway. I'm showing you. So understanding that these kind of solutions will help us something area. So area has got different altitudes, different. So if you see, say Los Angeles, no, the Las Vegas, Nevada. Nevada is completely place where it is desert, it's completely covered by mountains. On the other hand, California is a place where it has complete resource. So now they're utilizing those water resources to Nevada as well. And back, they have got something where these kind of hydro prototypes has been. And the last one is storage. We send it back to on the we use it for wire. That is not feasible when it comes to the generation of electricity. It is only a part of it. Because indirectly consuming something to generate energy. When it comes to, I feel like the equivalent. The Vortex is one of the design that I felt very convenient, where you can install it and see how this natural flow can be breakdown. So when you see this prototype that they have made, and they have been already utilizing it in real time also, but for easy and convenience for our understanding, I'm showing this animated video. So the natural flow that is flowing can be redesigned with a structure and that turbine as well. So now it has been covered, and if you just open up our natural flow of water into another direction, the same can be done, like the same water can be flowed throughout this particular aspect. And if you see, once the water is full, and you can understand, they just want to show that uh, any effect of it. And once the water flows, you can generate kind of an. And you see, these kind of solutions, or these kind of designs will help us to power up, see, our homes, or whatever the energies that we are using on a smaller scale. See, I think in US every household has got this separate electricity track that they have to run out. So that's a regular place that I've tried and automated. So this kind of process that helps us to understand how this hydropower can be utilized. Some research people are talking about China is uh, a lot of water flow, which is directly affecting the Earth's rotation. This on side, as per my understanding, that might have a cause when you construct dam and stop the flow of water to an extent. It will definitely affect the natural ecosystem. But I think on the other hand, we have to make sure that that will not population that we are talking about, because the height, when the increases a lot, huge of it going go with of the river hydropower, which will help us other area where these village people, they can generate. I think most of the agriculture areas on these kind of concepts, where they create a water, they'll water without having any hesitation. I think they can install certain wind turbines like this, so these power can be generated and can be utilized in return as well. So add on to this, like the first three we are talking about, mostly it is good on the other one side of the part. And when it urban, or when you talk about huge or big set of applications, solar, wind, and hydro are the biggest things. But the most underrated, and most people doesn't think of it, is like the biomass. And so, and the waste. So when we come to energy, the natural energy which people talks about, methane, and which can be regenerated, there are a couple of concepts that we can build on top of it. But of course, it requires a very clear understanding of how exactly we are gonna separate this plant waste or agri waste and create this biomass. Biomass, you can biomass is good view. Now government has taken a very big initiative. Government is already using this or ethanol. And if the north of India, Punjab, and blocked with a lot of all during the winter season, summer ending to Jan and all. What they said is, let's make it as all a country and pair, apart from the diesel and vehicles that we talk about, now the vehicles that they are with ethanol as well. So in an automobile perspective that we say, ethanol is one of the factor like countries in Delhi. Biomass that we use, I think most of the cultures see them, but unfortunately, we are not utilizing in the urban area. So we come down to these kind of creating the with all the organic and crop residue we have. It will be helpful for creating a best climate, creating the best utilization of energy. But you can see the bias on the gaseous side, anaerobic digestion and gasification. These three different types are the natural processes. So on picture wise, that way, you can see this spell. Most of the people buy. I think we can see the laundry persons, people who work with iron. So they buy and utilize the coal, and they start ironing a shirt, all the dress materials. But the same can be torrified, very natural, and which takes more time for burn and less smoke as well. When we are consuming the energy systems, it is very important that the emission that is going to generate, because it is indirectly affecting or directly affecting the ozone layer, and which is going to be residue of the smoke or the air that we are inhaling. So the Delhi based areas are mostly affected with all these pollutions, so that can be replaced by when whichever the coal or general burning that they are using, they can go with pellets. And on top of it, the biomass that is already there, I think most of us, if you see the plants that we grow at our home, so all these vegetable waste or the eggs and everything, the waste will just drop it on the plants so that it grows with much stronger and more fertility. So I think this is one of the area that we have to look at, the biomass. Maybe in a larger perspective, today it might not be so viable because of the lifestyle that we are working with, but on a longer run, biomass is going to be one important aspect that we have to look forward. And having said that, biofuel, now fuel, when you talk about ethanol or the petrol, which is a combination that ethanol for 15% or 20%. Right now the government of India has given the access for 12%. Now it has been 15. In next 2 to 3 years they want to go with 20% of ethanol in the petrol, so that they can reduce the pollution as well. So these are all the different energies that we can look at in a what to say, on a perspective of the uh, renewable energies and natural. So the natural energies that we can generate. So coming to the geothermal. So when it comes to geothermal, I think most of the uh, plants that we have got, like NTPC and other stuff, we they are utilizing the regular consumption. But when it comes to geothermal, this is an internal thing. I think China is using one of the popular geothermal energy that they have got. It is trying to take the heat from the interior side, so it is indirectly creating the heat, and from the core, earth's core, they are going to generate the energy also. So this is going to have a little technicality, but this may be utilized for a lot of industries. So when it comes to industries, these kind of energies can be utilized. And there are the different types of, either we use directly based on the sea heating buildings, greenhouses and spas and other stuff. And when it comes to GHPs, the heat pumps, when we talk about buildings that are heating and cooling, So based on the Earth's temperature, we can stabilize this. Though this concept is not more into the picture, but this is one of the idea that we can still work on, and a lot of research has to be done on higher side, because when we see the planet on an overview, we have a lot of different temperatures, and we work with different seasons. So based on the places, when for example, if you take San Francisco or in Nevada, as I said, they either go with higher temperatures of 60, 70 degrees sometimes, and they go with lower temperatures like -5, -10 also. So this is a way how these geothermals can also be helpful for a larger perspective. So in point to this, so when we come to this particular uh, topics of all these different concepts, solar, wind, and hydro is one kind of aspect that we can look at, and go ahead with the next upcoming energy requirements. But whereas biomass, geothermal are the biggest challenge, because they have to be created from the nature. And last but not the least, when we talk about tidal energy, so I think most of you have seen the oceans, and inside the oceans, of course I couldn't get the pictures, but I can still show you on the YouTube, the tidal energy, which is going to generate a huge massive energy based on the waves. But of course these waves, if you see, let me show you a small video. So tidal wave energy, where these are very recently been updated with these kind of aspects. So though based on the design factor, if you can see the wave movement, so based on the wave, this goes the hydraulics functionality. So it goes like up and down. These natural movement which is happening because of the waves produces energy. I think in Dubai or the outside of the Dubai, most of the places they are trying to install these kind of tidal wave generators. And these generators, of course, if you ask me whether we are going to get huge energy or not, as per the constraint is saying, all these renewable energies are costly. They might take big setups for installations, and on top of it, it is something the outcomes of it, the power generation or something like that, it'll take a uh, little kind of energy consumptions, or installation process might take time. Just let me show you one more, which is based on the turbine. Apart from this, uh, no, this is an internal one. So this is one kind of internal design that you can see, the tidal one on the picture. So this is something the internal turbines under the sea. So this will help them to generate the energy. I think this video might help us to understand. So it has got AI based stuff. Okay, we'll leave it for time being. So tidal energy is one of the important aspect that we have to look at. And though it is little difficult for installation, or it is going to take time for us to present the generation of outcomes also. But on a larger perspective, as everyone knows, when compared to land, there is 3 times much space on the oceans, right? So we can use this tidal energy as one of the important renewable energies, and at the same time the energy that is going to be generated again has to be taken on a cable kind of system. So on top of all these things, people right now talking about hydrogen, but when I from my end, my perspective, hydrogen energy is something again we have to talk about solar, we have to talk about wind, or some or the other way we have to generate this hydrogen energy, which has to be again clean energy. So talking about green energy or clean energy, we will have talking about hydrogen. So the natural stuff that we have got, or the process that we are going to make, maybe it is little difficult for the storage, for the generation, and for establishment, as we are not going with nuclear plants. I think most of you know that we have lot of resources of what to say this. I'm sorry, the nuclear plants, but unfortunately the effects of nuclear plants also has got a lot of cons as well. So that is why government of India, or at least some state governments, are not ready to go ahead with the nuclear plants, because once they go with nuclear plants, if there is a small mistake happens in nuclear energy, that will affect a larger value. So comparatively, they are coming up with hydrogen setup like Adani, Ambani. They are establishing a bigger version of hydrogen plants. And I think four-wheelers as well as the heavy trucks are coming up with hydrogen cylinders where you can fill hydrogen and you can execute it. So hydrogen is going to be one more resource for us, though it is taking time, it is a costly affair. I think over a period of time, see how like solar. So when government of India 5 years back they said like solar will be getting subsidies and all, it's because of the establishment usage parallelly China imports has affecting a lot. We are unable to get that under subsidy, so people are not ready to use it. And when we comes to the calculations, I think Indians are very price sensitive market. So the price sensitive market also needs a price sensitive solutions. So in that direction, generating hydrogen either with solar or something else as an input energy and storaging of hydrogen is a bigger challenge. But we will further go with these kind of energy. Lot of mechanisms work. So hydrogen has got one important aspect, and on top of it, we have sorry. This is how the process of the green hydrogen works. So here you see about like hydrogen is just like H2O. The water we are going to do the electrolysis part, and then we generate separate the hydrogen and which is air. But the challenge here is on side. So we're going to burn the water, or you the water based on solar or based on any other this comes with a complete green energy. So now the different kinds of solutions that we have as renewable energies, we have to think as a solution compatible to the companies also, because all solutions that till now that we're talking about are huge, massive, lot of investments that are taking. Maybe like it might not take, but this is going to take the higher end. And these kind of resources, rather these kind of energy systems will help us to reduce the usage of and other oil and natural resources. If these alternative, recently, like of India was talking the scarce electricity in areas. So now we are looking for alternatives, and if the alternatives rate, the I think we will be on a sustainable instead of using this coal and other natural resources that we have to the ultimate concept of different concept. And having process can also can also be said as hybrid model. So when I talk about hybrid model, either solar wind energy or hydro wind energy or biomass or it's like multiple components that we can try out. But it is all depends upon possibility with the climate conditions, and certain areas are good with all these resources that we can support with, and companies also has to come out with different kinds of solutions on these particular lines. So these are the different aspects that I'm sorry. These are the different aspects that I'm looking at from the renewable sources that we have got. And if you have got any suggestions or if you want to put any points on top of it, I'll be more happy to connect. And this is how the upcoming resources that are there. So from my end, I think I have given my information. So this is my contact details, and you can connect me over LinkedIn. And thank you so much for giving an opportunity. I think I can open up the floor for a certain set of questions if you have, or we can just go ahead and discuss the possibilities of the next generation solutions that we have got. So
Yeah,
hope,
Venkata Reddy, yeah.
yes, sir.
Yeah, this is Professor V.V. Subbarao.
Yes, sir.
Yeah, you have given a very valuable and informative lecture. Thank you. Uh, yeah, can you throw a light on OPV?
Yes, sir. So
Yeah, we
when
are solar panels. Everybody is working on it, and the latest one, OPV, is the latest one. People also looking at it. Seems.
Very simple, sir. When it comes to this photovoltaic cells that we already have into the market, I think place like China and place like Bangalore, comparatively, if you see the market ratio, whatever we are producing in India with a quality, you have four different qualities of solar panels that we have,
Yeah.
and whatever the value that we are generating, or the establishment cost which is taking for production that particular solar panel, it is 10% less in China. So that is how it is little difficult for our establishment and the battery systems that we need to do it. Now, what OPV does is organic photovoltaic cell, which is a natural one and which has got a little flexibility when compared to the other stuff, right? So OPV will help us to generate more energy in a very less space. And whatever the energy that is there, you are going to generate maximum. For example, if you see, when we establish a normal solar panel, they will go with the direction of sun, as well as we have to see on which direction we are placing it. So there is a certain angle that we have to look at and certain position that we have to look at. And based on that, we can generate the maximum consumption of the energy from the solar side. But whereas in OPV, because it is being flexible, and if you can see the area, and those stickers that you are looking at is like, how 5 volts, 5 watts, 10 watts, 20 watts panels that we have got. It is a similar line that we have got. So using those panels, we can stick it anywhere, and those will generate more energy. But of course, it is little costly right now because the manufacturing is not happening in India. It is happening outside India. But if we can put those into our manufacturing stuff, I think we can utilize the maximum stuff of the solar panels.
Okay, sir. But right now in the Indian market, we don't have these things.
No, sir.
OPVs.
Yeah,
Uh,
we don't have it in the Indian market. And
mm.
we have one more which is coming up. Of course, I have to tell you in the two directions this one. The glass plate, the photovoltaic glass plate designed by people. I don't know whether they want to release it or not, but they have already been trying home. Instead of windows, they are going solar panels where the glass absorbs the energy and generates the energy for us. But I don't want to discuss that because the technicality, we don't have a lot of information on that. But this
Oh,
OPP has got a lot of protection possibilities. Governments accept. I think you can go with some research papers looking at it. And
yeah,
if you see that is flexible, we can talk to companies and we can ask students to kind of ideas so that that in India as well.
yeah. And another thing, you said tarified. Yes, that is also, it looks interesting. And I think,
Torrefied pellets is something that by our own. See,
yeah,
generally when it comes to MSMEs or when it comes to small companies, when they are using some in the burning or generating energy from different locations, steel plant, they use a lot of coal for
yeah,
burning the furnace or those particular areas.
yes, yes.
These pellets they are making, like when we were discussing with one or two companies for the mass, biggest challenge in Indian markets is they don't understand the technicality.
Mm.
Because coal is something that since years we feel like this is easy, we can buy it. But pellets, we have certain process. So we have paste, then we have to compress it, and then we have it with some pressure, and then we get the pellets. And once you start selling the pellets, I think, as you said, like it is going to be one interesting aspect that Indian community can, because
Yeah,
most
that's
of
what. Mm.
the laundry people or the iron people and other, like I think it is something like replacement of your plastic cup to a mud based cup, right? So for teacups, it's that we can replace in most of the places.
Yeah, and what another thing is you said the integration of the models.
Yes, yes, yes. So if I believe, like, in a longer perspective, every apartment which is there right now in India, as you already know that, panel water heating or solar water heater that we have already seen. Now they will come up with wind turbine panel. So they'll
Oh,
come full. You
mm,
can check out on online also. I can share.
mm.
There'll be one pole with a wind turbine and solar panel which is going to be there, and there are couple of poles that they're going to have poles, and that is going to be connected for our lift, for the all the lights that we have corridors or in the common areas like that. And governments will come and say that, every 10 flats or 20 flats should mandatory have these kind of setups for sure. Upcoming days, governments cannot come like, general electricity. They will definitely ask us to put some, at least 50% or I think they have to go with the solar panels models.
Yeah, wind trees. Integration of these to become a good creation for a
And
domestic purpose.
yeah, and coming to Wintry, sir, apart from Wintry, I worked very closely with the turbine design. So the turbine design is one critical aspect of the people are not very much interested in that, but the material, the flexibility, and for a very slow wind, if you can turn of times, because I was very closely working with one of the projects, and it is like 4 feet tall, and if you just flip it for like, just like blow, gen 3 volts with a very small amount of current. That kind of designs will definitely help us for a massive production future. Though people are not talking much on that those lines, but if that the picture, I think most of the industries, if you see, there is a top, there is a rotation. So kind of thing, utilized in the wind trees. So that is one aspect that people can look at for research also.
Yeah, but usually the wind turbines we require a speed of 5 meters per hour.
True.
But this vertical type of wind trees, vertical turbines, these are called vertical turbines,
Yes.
help us run below 5 meters per second.
It all depends upon the
But
designs.
they, they have to combine the all the turbines. That is the all.
True, true, true. Rightly said.
It is very nice, sir. You have given a the insights of the renewable energy sources. Really
Yes.
hope the topic it seems.
And
Thank you very much for your valuable speech.
thank you, sir. Add-on is something like, all these energy resources that we are talking about.
And
There should be a battery management system that also we should look on,
yes, 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 that
because
is
on
right.
one
The
side,
storage.
yeah, storage. So storage has also been a very important aspect that we have to run on, because coming to batteries, these lead acid or lithium ion, uh,
Yeah.
yeah. So these things also I would like to point it out right now, so that people who does the research or, who wants to kind of thing. Upcoming days, energy aspect is concerned, as the first AI based data center. So those data centers needs a lot of power. I think over here, if you can do some research, or centers are going to be in India, and they require a lot of power, and your solutions can be worked out. And there is one start from T Hub have generated 1.5 watts with a very small burning of a molecule or something like that. I don't remember exactly, but I can share that for the group where Sir can transfer. That is one kind of a design they're looking at, like Government of India, and giving a lot of funds into that directions also.
And here, finally, research scholars and MTech students, PG students are also there. Could you throw a light on the employability skills, opportunities in this sector?
Oh, wonderful,
Yeah.
sir. So yeah. So when it comes to these job opportunities, or most of the research people, I think this is the right time for you to tap on this. 99%, most of the startups, they come out with the product solutions, but they don't come up with the analysis part. So they'll have ideas, they'll have concepts, or companies want to build or design. All those working over there, either they have been into the management or they might be into the product development, but they don't look at the energy perspectives. So when it comes to the energy perspective, every industry, every place needs their energy solutions renewable. So when it comes to the employment part, I've seen from the perspective of US, all the data centers that are there, they're lacking out of it. And if you see right now, Amazon or Microsoft or big companies, they're investing more into the renewable energy systems, or people who are working in that directions. So as a research scholar, or research people who have the papers, you can go and tell them that, sir, we have got company, or this is the model that we are looking at. If you make me as an R&D member, help you out. So there are employment opportunities, but of course that is not like regular outside people talking about. But on particular platforms, you can still have a lot of career opportunities in that particular direction, but more into the research side, optimization of the energy solutions, and generating simplest solutions. See, IoT, anyway, because of the internet, that is going to grow, but optimization of energy solutions is also going to be an important aspect from the perspective of the jobs and opportunities.
Yeah, I think we have to integrate the AI tools to this renewable energy systems.
100%, 100%. It is something like every day how much energy that we are using, take the
And
data, put it in the algorithm, and see, okay, the next 5 years, this is going to be your utilization. That is where Meta, Microsoft, and AWS are putting a lot of money, because AWS of data with them, and their data centers need a lot of power. I can share you one video on that, particularly the energy requirements for data centers. There itself has got a lot of scope.
and not only that, but here the solar climatic conditions. AI tools are helpful for predicting the climatic conditions and for wind turbines, the wind flow.
Yeah. Sir, on to that, so very recently I've been to for the CES, Consumer Electronics Show, which happens every year. And I just want to put it in your notice, being this is a very good platform. CES 2025, just go through it. There are lots of companies that are talking about AI and these kind of energy resources and all. And what happens in next 4 years or 5 years, it's like you go to future and coming back, this kind of event. I'm very lucky and fortunate to very recently I've been visiting all those, and seeing all those. What I understand is AI is going to be used in everywhere. Talking about algorithms and data, or the data driven outcomes, AI is going to be used in everywhere. So please make sure during your research also, those kind of solutions will definitely help the opportunities, job opportunities.
Okay, thank you very much, Reddy garu.
Oh,
But
listen.
yeah, now session is open to the participants. Participants can with the Reddy garu, Venkat Reddy garu. Yes, yes, nicely as presented, sir. Thank you very much. You have given a valuable information to all of us, sir. Thank you once again. Thank you.
Thank you, sir. So any questions open for people? Thank you, Lakshmi garu, Venkat Prasad garu, and Sulochana garu.
Reddy Pawan.
So anyone who is working in this particular directions of
So their faculty friends who are working in the area of advanced renewable energy systems, who is you can get it clarify the doubts. Students, thermal engineering students.
So thermal engineering, I think you have to do a lot of research, and you have got a lot of scope in the upcoming years, because every industry has got a lot of scope in that particular department,
Yes, sir.
engineering. Or any suggestions that you want to give, or any topic that you want to mention, please do. That will also
So,
help me out.
renewable energy technologies also, we have a specialization in Institute of Science and Technology of University, sir.
Okay.
The few faculty were also joined this session.
Supriya is there. Supriya. Reddy Pawan.
We have a
Yes,
PG
sir.
Yeah, yeah,
course.
you interact with Venkata Reddy garu.
We have
Okay,
a
sir.
PG course on renewable energy technologies, sir.
Yeah.
Okay.
Wherein interdisciplinary, triple E students and mechanical engineering, so those who are interested in pursuing in energy sector, we have a special MTech programs offered by IS Technology JNTUK.
Okay. Actually, when it comes to this, because I personally worked with EV, so when we are discussing about electric vehicles, the biggest challenge again is the perspective of two, three. One is the battery management system, another one is the fuel cell. So lead acid batteries have got one kind of issue, and when it comes to this, batteries have got the and now they are different batteries, like aluminum batteries, sodium batteries. So I think that aspect of thermal energy should be focused on those batteries. India just are totally different, and we have a kind of mechanism where to reduce temperatures while utilizing the batteries also. And Arun Reddy garu, energy storage using sensible heat modes and its scope. See, when it comes to this energy storage, that is the challenge that I was telling. If you have heard about the very recent, like 1.5 year back, the Ola battery has got burned out, or most of the electric vehicles have been burning. The challenge is all the electronic components, if they are under vibration, all the electronic components that are under vibration will definitely generate some temperatures, or some energy disturbances. Those disturbances, if they are not handled properly in a battery, because the battery blast and battery issues are because of that particular thermal storage of that energy. That is why government of India said all the EV companies to put a sensor which tells about the battery temperature while running, or while going to the maximum extent, or utilizing the maximum energy from the battery. But the challenge is when you're putting sensors inside, those sensors will give the out temperature. They're cut because we installed a sensor saying that once the temperature raises, the motor stops working, the battery stops working. But the unfortunate thing is, what happens if they stop in the middle of the road? That is again a challenge. So there are certain aspects that still those kind of models have to be run on. And of course, EV is a very new market. They don't have the data. All the problems that we are seeing now is more into the developments. And parallelly, on a hilly areas, it is difficult to use electric vehicles. So I'm not trying to go on the other side of the aspect, but electric vehicles have batteries, and those batteries have these thermal issues. And once these are thermal out, and we massive is happening. So I think those kind of also to be installed, which works at high temperatures. Those are very sensible, generate not in the middle. The such research is under process right now. And so, is there any software to check PV feasibility study apart from Homer? So I don't have understanding on that. There might be certain softwares, but I'm sorry, aware of those.
Ma'am, we are preparing. You are ready.
Dilip sir, you're on.
I'll call you, ma'am.
So I'm
Can
sorry.
you able to join? Yeah, yeah. It's concluding. Mm, 5 minutes. Thank you. Thank you.
So anyone who is doing a PhD, or who is doing research on centers, or the if possible, please do connect me. I can help you out in getting connects with 2 3 companies who are kind of solution. Be a person or something like that, and they'll be paying you on the research that you do, because companies have got a lot of ideas and a lot of requirements are there, but unfortunately a right manpower, or right people who are researching it is little difficult, because we are incubated from T Hub. So we have connects in T Hub, we have got connects in multiple incubation centers, so we can help you out in that line as well.
Sir, you are
This,
what is your brand and you and your will
so
climate, because you are very curious about the climate changes in the society. So
yes.
there will be entered into the electric society. So can you introduce your experience in?
Sir, actually, see, earlier what we have done is, like, we have worked with 3 4 companies for the product. So unfortunately, they had a lot of issues with the cure, and had a lot of issues with the product outcome also. So when it comes to the quality and when it comes to the outcome of the particular product, it has been really difficult. I think you have seen, oh, you have seen, right? Ex- Most of have got a lot of issues. So involved in product development. Unfortunately, it doesn't worked out well. That's why we have and now we are working on the customer centric based EV systems. So we have installed charging stations. We have seen the utilization. The biggest challenge is India is a price sensitive, and at the same time, they don't understand the over time it mode. So that is why only the big players are there right now. TV are the big other companies, Ampere, Pigos, something like Chinese models. Also, a lot of things are there. So right now we are not much focused on this particular track, because we burnt out a lot of cash in it, and we have utilized a lot of time in that particular area. So now it is where software based, where electric vehicle will the data, how much of that they have made, and all those, they are pulling out the data right now. So that is where we are looking at. And another question is, any instead of using AI in for yes, yes, that's what I was trying to of renewable energy sources that they are being already utilized. So Anantapur, we have got wind turbines. So how much wind generating this energy per year, per month? Those calculations, or what small changes that we can make. Apart from a topic called digital twinning. Digital twinning. So that is their most important aspect right now in this optimizing using those models. Now, analyzing it. So if you can get the database of how much you have generated and how much been utilized, I think that optimization and implementation can be done, and that gives a wonderful solution in the real-time scenarios.
Another question is there any ways and means by which we can make two-wheeler also hybrid?
That is uh, solar doesn't generate aspect. On the other side, there are people who are trying to work on free wheels, like the rotation of a free wheel and generating the energy from that, and again storing it. But yes, it is little to put energy that is generated on the second part with very very less primary energy storage that we are going to use.
Good afternoon. Uh, speak. I am Devdeep speaking from West Bengal. I am a
Yes,
lecturer in KG Engineering Institute. Actually, my question was, is there any use of hybrid energy storage? Because I have seen some papers regarding battery and supercapacitor, they have been used together to
true.
increase the battery life. So, is there any implementation in Indian vehicles?
So you come up with that supercapacitor, no sir. So when it comes to supercapacitor, you are going to store some energy which is similar to like battery. But the challenge here with supercapacitor is like how
Actually,
much energy that you can store and what is the size of that supercapacitor if you want to store more energy. That is the biggest challenge. On papers, it is still there. It is working. Hybrids will work. But when it comes to practical, it is little difficult because the we are going to generate in the combination of hybrid and the storage aspect, it is little difficult on two wheelers. Maybe this will work out for four wheelers or heavy vehicles, but not for two wheelers or three wheelers. I hope you got my answer.
okay, thank you, sir.
Right. Thank you. Can you share links? Definitely, I can share you a lot of links, which all the topics that we have talking about, and there are few aspects of papers also. Maybe I'll be sharing you over a mail or something like that to Dilip Gar or the faculty.
Sir,
Uh,
one more thing is, can you please share, okay, hybrid energy?
Sure.
They want references, sir, some references, articles
Definitely,
with
sir.
which they become
I can share
capable of understanding, sir.
by tomorrow. I'll share it over a mail and you can share it to the participants, because all the topics that we are talking about are the upcoming research, or that is more required for the country like us, because we are the massive usage of the energies. And unfortunate thing is, because of political pressure, or because of societal conditions, we are not running any nuclear plants or something. So nowadays we are using the 7, and we need lot of and I don't know how many of you have heard this particular topic called solar panels across the moon. They had a plan saying that they want to put up a pile of solar panels across the moon where the sun's energy is going to be absorbed to the maximum, and that is sent from solar panels through wireless to earth. So that is one more aspect that you can look at. And when it comes to space, there is a lot of research that is happening to generate energy. So they want to put some set of hexagonal plates, and they want to put some energy resources over there and pull out maximum energy and push it through wireless transformation. So these kind of things are also happening.
Venkata Reddy, finally, it's my request uh, on behalf of the institute. Yes, here we have two disciplines, sir. Thermal engineering, PG disciplines, thermal engineering.
Okay.
Hello.
Yes, sir.
Uh, thermal engineering, and another discipline is the renewable energy
Okay.
and environment. Yes, these are the two PG programs we are offering, sir. Yes, the students are looking for the internships, and if you could provide the opportunity for the projects, they'll be very happy. We also will be happy.
Definitely, sir. I'll be more happy to connect, and we'll definitely share the information. And I'll try to connect to some of the companies who are already working in this particular lines.
Yes, we'll be in touch with you, sir, and our students also will be in touch with you. You help them,
Definitely, sir. Definitely.
particularly yeah, what you said in data centers, AI applications.
I'm more keen into it. So tell them that, that has got a lot of scope in the upcoming days.
Yes, yes, that's what I keep on telling to my students. Yes, you update and use the AI tools for the core domains,
Yes.
mechanical and renewable energy, or wherever it is possible. But what you said, everywhere it creeped into all the domains, these AI tools.
Yes, sir. Yes, sir.
Mm. So thank you very much, sir. Thank you.
My pleasure, sir. Thank you for all the participants for being into the session, and I would like to happy to connect later on for sharing a lot of insights. And thanks once again for everyone for making this possible. Sir, thank you so much for giving me a wonderful opportunity, and looking forward for programs like this.
Thank you, sir. Thank you very much for enlightening and empowering and educating us on advanced. We are really seen that the solar our tapes. It's a really new for us. Solar tapes and just pasting over the walls will also absorb the sun energy and deliver the renewable energy. Storing is very good, sir. That's really appreciable. And thank you for accepting our invitation and sharing your experiences with the university ATAL participants. Thank you, sir. Thank you very much, sir.
Thank you, everyone, sir. Bye.
Dear faculty, we have come to the end of the first session. Soon, without wasting our time, and we will start our second session in our mixed. Dr. She's a Nabanita Dutta. She's hardware engineer, R&D, power electronics. He pursued his degree from electronics and communication, electrical engineering. And I would now request our colleague, assistant professor of mechanical engineering, University College of Engineering, Kakinada, Srimati Manasa, to introduce our guest of the second session of the day.
Good evening, one and all. I am B. Lakshmi Manasa, working as assistant professor from the Department of Mechanical Engineering. I am delighted to have the honor of introducing our next speaker, Dr. Nabanita Dutta, Power Electronics Hardware Engineer, ESAB India Limited, Chennai in R&D. Previously, she worked as a research scholar in VIT Vellore, doing a collaborative research with Danfoss on system. She has more than 5 years experience in the field of power electronics and drive, artificial conditional monitoring, health monitoring, and feasibility studies such as detection in industrial pumping systems, hydraulic, mechanical, and in electrical anomalies also. So life cycle cost analysis of pump and a motor, load testing of induction motor, TMSM motor, designing of power converters, and she has published 16 journals and conference papers and 2 book chapters in prestigious journals like Taylor and Francis, Springer Nature. Currently, she is reviewer and editor of various journals like IEEE, IET, and Springer Nature. She is an IEEE member and a part of IEEE Kolkata YP since 2018.
Thank you, Mrs. Lakshmi Manasa, for introducing our guest speaker of this session. And with this short introduction, I welcome Dr. hand of the to take up the session. Yeah, I will just stop my share my screen, madam. You can share your screen.
Yeah.
Please.
Everyone can see my screen?
Yes, ma'am. Yes. Yes. And you put it in a presentation mode. Yes, done, madam. You can, the floor is yours.
Sir, thank you, ma'am, for the good introduction. So basically, I will talk about today about the application of power electronic components in smart energy system and renewable energy application. In ESA, basically, I'm working as an engineer and component engineer, where every day I with the components. Company is not a based of renewable energy application. It is a fully building machine company. But the application is power electronics. Today I will talk about more on the application in the renewable energy system, where the power electronic components are used and how to impact the power electronics and smart energy system, energy storage system. So the agenda I have fixed for this, followed by the introduction, then power electronics component, basic components which are the use for daily basis for renewable energy system, energy storage system, smart grid integration, and I have chosen to make the participants easily to understand the how the solar panel using. So then advanced semiconductor based components technology like SiC, the modern technologies implement. Then challenges facing in power electronics for smart energy system and renewable energy, and the future trends in power electronics and renewable energy system. Followed by some. So power electronics is the field of engineering that deals with conversion, control, the regulation of electrical power using various electronic devices, and it efficiently for the managing the power to meet the requirements of various applications, and from the industrial equipment to renewable energy system application. The key component mainly for power electronics we are using generally converter, inverter, rectifier, switching devices, then various types of controller, then for EV application, UPS system, this thing. So importance of power electronics in mainly in energy systems and renewable energy system to convert the energy, in enabling renewable energy integration, then grid support system. There are two systems we are using, off grid and grid types, and energy storage management, then harmonic reduction, then enhanced control and flexibility, reliability and durability. So basically power electronics devices, when we use for industry base, there are three types of devices are there. One is low power voltage devices, another is medium power voltage devices, and another is high power devices. So low power, which are using power electronics components, are typically used in the applications where the voltage is below 1000 volts. These components are mainly integral the part of the system of solar power, electric vehicles, and industry machineries like consumer electronics, mainly semiconductor devices, that's Schottky diodes, the low voltage diodes we are using, then PN junction diodes, then transistor, Zener diodes, then BJT, bipolar junction transistor, then IGBT also. IGBT generally used for, it's depend on some low to higher power voltage everywhere we are using, but it depends on the application we are using. Then some passive components, capacitor, resistors, electrolytic capacitor to store the energy storage system, ceramic capacitor, then film capacitor used in DC-DC converters, some for filters, small filters, EMI separation, then power conversion components, DC-DC converters, then buck boost converter. There are lots of converters are there. Buck converter, boost converter, cup converter, buck boost converters, epic converters, then smaller inverter for UPS charging system, then control devices also, then relays, electromagnetic mechanical solid state relays, overcurrent for short circuit protection, then magnetics also, smaller transformer like current transformer. These are things are using for the low voltage application. So then current sensor also, smaller current sensor, these are also used for the low voltage application also. now I will tell about the medium voltage. Medium voltage mainly using for the some drive system and for charging system, motor control, and for the PV inverter we are using. Then medium voltage is the voltage range for 1000 to 3.6 kV. Then commonly used for mainly for renewable energy, transportation, utility system, and power diode, transistor, in transistor also, MOSFET, silicon SiC based MOSFET, which are voltage up to 1.7 kV can be used. And nowadays SiC GaN based devices also for the emerging technologies are coming for the high power application. Then passive components also using, then the snubber capacitor, DC-link capacitor, then for medium voltage filter also using. These are coming under medium voltage level components. And then high power voltage components are using in large power sector like wind energy, power grid, railway transportation system. They're using the high power voltage system, the surge arrestor, HVDC converter, high voltage transformer. These are coming under the high power voltage circuit. Then fact devices, STATCOM devices, then the vacuum circuit breaker, then magnetics, then high voltage transformer, and voltage sensor, high power current sensor, some heat sinks. These are all come under high voltage application. So now I move to the overview of smart grid energy system. So basically the smart grid energy system is integrates the advanced technologies to optimize energy production and distribution and consumption. It uses real-time data and automation and intelligent control mechanism to enhance efficiency, sustainability, and reliability. Nowadays we are using some AI tools and AI application in smart grid application also to make it more optimized and make it more emerging technology based system. So the key features of smart grid energy systems are integration of renewable energy sources, real-time monitoring control, bidirectional energy flow, then energy storage, then using of automation and artificial intelligence. These I will elaborate these things. The integration of renewable energy means to support the distributed energy sources like solar, wind, hydropower energy sources are seamlessly integrated into the system. Then flexibility of the energy generation, handle the intimate the more energy efficient energy production in the renewable energy sources like advanced forecasting. For the using of AI tool, we can forecast the power generations and what are the faults happening in the system and the balancing techniques also. Then energy storage integration incorporate battery, supercapacitors, and other storage systems, storage generation, consumption, and grid health. Two-way communication, directional use, based sensors using for real-time monitoring of the system. Smart meter is using for the monitor of the energy uses in real time and provide the feedback to both utilities and the consumers. Then energy efficiency and optimization, then adjust the energy consumption patterns based real time grid and pricing signals. The automates the control of the energy consumption in case of homes, building, and industries for optimized uses. Then uses for the loss, reduce the loss and minimize the losses. Reduces transmission and distribution losses through advanced power electronics and optimized grid operation. Then microgrids operate independently for the coordination with main grid and enhancing reliability and reducing dependency on the centralized system. Then provides the backup power for the outages of the energies and improving energy security also. Then predictive control-based techniques is using AI-based techniques that for the energy generation and distribution and consumption for the health monitoring of the system. Then detect and isolate the faults automatically if any faults happen. Suppose previously in the old system we are using not using the AI techniques, means we need to wait for the alarm is coming or any faults, fully the system should be disrupted, then need to work identify the faults in the smart grid system or the total system. But whenever the AI system, AI based tools have been generated, it is possible to detect the fault at the beginning stage of the fault, and it can be detect the faults at the beginning stage, so the losses can be minimized by these techniques. So this can be uses for the battery applications also, and the electric vehicles is the main application where these systems can be used. Then the key components are using for the smart energy systems are smart grid, distributed energy resources, energy management system, energy, electric vehicles and charging infrastructure. The main benefits of smart energy systems are efficiency, sustainability, and reliability and flexibility. Smart energy systems integrate advanced technology, communications, and networks, the innovative solutions to manage energy generation and distribution and consumption efficiently. Support the distributed system like solar, wind, hydropower energy systems to integrate the total grid system. Then handles the intermediate energy production by renewable energy resources using advanced forecasting and balancing technique. Then incorporate the batteries and supercapacitor, but supercapacitor mainly not using for the industrial purpose. It is mainly academically or theoretically paperwork, some work is have been done, but mainly for industrial application batteries are only used for the storage system. And for the real-time monitoring, sensors and IoT based devices are also using for energy generation, consumption and for grid health system. Monitor the energy uses in real-time energy and provide the feedback for both utility and consumer. Then adjust the energy consumption patterns based on real-time grid requirements and principal signals. Then automate the controls of energy consumption in homes, buildings and industries for optimized uses. Then loss minimization reduces transmission distribution losses with the advanced energy advanced power electronics techniques to optimize the grid system. Then local power generation microgrids operate independently and coordination with the main grid and enhancing the reliability and this resilience. Then intelligent control system, AI and predictive machine learning techniques can consumption. So self-help monitoring also is the part, self-monitoring also is part of these techniques, and reliability enhances the grid reliances and reduces downtime through the predictive maintenance. Then adapt various energy demands and integrate the new technology that is also AI based to make it more flexibility. So mainly smart grid energy system or any our energy system categories with generation, transmission and distribution. Distribution can be both way. One is residential uses and another is for commercial and industrial purpose. Residential means the solar rooftop system or any home display unit or battery backup system the for home purpose, or home some pumping system, solar power based power system. In the commercial application we get the electric vehicle charging station, then distributed energy sources, smart building application. There are lots of applications are there. And transmission we can make it grid to be the automated system, then remotely we can control, which come under condition monitoring and health monitoring system. Then the intelligent substation, nowadays the old process has been removed, and no new techniques are introduced, and these are coming under upcoming days also. So mainly for the this other system. So power electronics, now I will discuss with various power electronics components like power converter, semiconductor switching devices, passive components. Already I told what are the components are there. Still I will elaborately I will describe. Then control and protection devices, then advanced semiconductor materials and sensor. So these are the key components. The smart energy system integrates advanced technologies and renewable energy, where for the renewable energy, the using for the solar photovoltaic system, PV system, wind turbine, and then for the hydropower plant and biomass system, geothermal energy system, and traditional power plants there where we are using coal, gas, nuclear power plants. So solar power plants mainly using the solar panel, the battery backup system, the types of inverters for the grid integration, then wind energy system, wind power system, wind turbines, generator, wind power generator, then energy storage bidirectional converters for the battery, and the smart grid obviously for the voltage frequency regulation using advanced inverter techniques. So these are the mainly application of power electronics components. So solar panel, if we play a power electronics play a vital role in the solar power application, because power they are using solar which application. So we are using inverter and electronics utilize MPPT controller techniques, continuously adjust the electrical operating point and modules of arrays, ensuring they operate at the peak level, maximum of energy harvesting. Then power electronics ensure the AC power then matches the voltage, frequency, and phase. In battery storage, power electronics match the charging and discharging cycles of the batteries, ensuring optimal performance and longevity, and the power quality improvement also possible power technology. Then energy management system, this monitor and control the energy storage using supervisory control, this application, data acquisition system, real-time monitor operation possible that automate the grid automation, then ensure incorporate, there are various standards are there, IEEE standard, IEC standard. Based on that, it's smart meter system, and it is possible, there are lots of applications are there in the solar power system for the in the field of power electronics. So basically, key components of power electronics and solar power application, the major power electronic components which are photovoltaic modules like solar panel, DC to DC power converter, inverters to convert DC to AC, then charge controller like PWM controller, MPPT controller, energy storage system like battery, protection devices like fuse, circuit breaker, and surge protector, then monitoring and controlling system, isolation transformer. Here I given one diagram of grid connected and off-grid system. There are two systems are there. One is off-grid system and another is grid connected system. Grid connected system, there is grid, smart grid, grid is required, power grid is required. But in the case of off-grid, there is one charge controller and battery storage system to store the energy. This is required. Off-grid system is mainly used for the remote places where it's not possible to install the grid connected system. Suppose in mountain area or remote area where we cannot fix the grid connected system, there we can use this off-grid system, these things. So now there are various types of inverters in using in solar power system, because solar power, that solar panel which is using for the main component of solar power application, that is is DC. So we need to convert it AC because our household applications are AC. So for this conversion, there are various types of inverters are using string inverters. There are lots of inverters are there. Upcoming slide I will tell. Then DC to AC conversion for the maximizing the energy harvest, grid synchronization, monitoring and communication, then safety and protection, then battery integration and management. So fundamental is to convert the what are the DC power to generate the convert to AC power. Then using MPPT controller technique to ensure the solar panels to operate at the maximum power point level. So it can adjust the electrical operating point to solar panel to extract the maximum possible power and enhancing the overall energy efficiency of the system. Then inverters ensure the AC power that generate is synchronized with the grid voltage and frequency and phase level. This synchronization is critical for safety and the efficiently feeding solar power into the grid. Modern inverters often come with monitoring and capabilities that provide the real-time data on the system performance, including power output, efficiency, and any faults or any issues. Then safety, for the safety and protection, inverters detect ground faults also to shut down the system to prevent electrical shock and equipment damage. Then battery integration and management, hybrid inverters also using nowadays to often include the battery management system to optimize the charging cycles and enhance the longevity of the batteries. So mainly 6 type of inverters we can see, that is string inverter, central inverter. String is the main inverter, central inverter, micro inverter, then power optimizer, hybrid inverter, and battery based inverter. So suitable for the residential and smaller application or medium voltage application for the solar panels, string inverters are used. And the central inverters are used for the large power plant, large solar farms, or the storage system, or the parking area, or the charging system. There the central inverters are using mainly. Then micro inverters based for the residential installation for the partial shading, choose complex roof structure where the panel level monitoring and optimizations are required. Then power optimizer also used for the residential and both commercial purposes are using for the energy productions and for the partial setting and varying panel of orientation. Then hybrid inverters are using ideal for the system include energy storage, enabling the use of the stored solar energy during non-sunny period and during power outages. And the battery backup system, battery based inverters are used for the off-grid application where the continuous battery backup system is required from the grid tied system or power supply required. So another important components is a charge controller, because if we use for the off-grid system, we need the charge controller for the continuous charging and the storage of energy. These are mainly for the solar power battery backup system is using. For these mainly pulse width modulation control and maximum power point tracking MPPT controller technique, mainly these two techniques are using. Then PWM charge controller is using for the switching mechanism to gradually reduce the current to the battery as it approaches to the full charge. If it is fully charged, it will be disconnected and maintaining the voltage at safe level. Then it is cost effective and reliable. The small off-grid system, they are ideal for cost cut. The small system, they cost sensitive with it a very lower cost. If anyone wanted to install the basic charging stations with the converter based techniques, then it is mainly used. And if we suitable for the installation where PW cost or lower cost of PWM controller also is using where higher efficiency is required. There it is using. So mainly the benefit of MPPT is it is a continuously adjust the power modules of the arrays and electrical power operating point to ensure that the system will operate at a maximum high speed. And solar panels have a non-linear power output curve, and their power output varies with changes in sunlight and temperature and different load conditions also. So for this reason, MPPT technique is the best suited method. MPPT works with the monitoring and adjustment, and for the optimization technique, for the where the optimization is required, their MPPT techniques are mainly used for charge control, grid tied inverter with MPPT, then hybrid inverter, micro inverter is using. The benefits are efficiency is increasing, better performance in different variable conditions, and maximize the energy harvest and improve battery life also. So there are lots of DC-DC converters are using in power electronics applications in solar power system. Buck converter for the step down purpose, boost converter for step up purpose, and step up the voltage. And buck boost converter, mainly buck boost converter are using for along with MPPT technique, and it's a complex module. The buck boost converter is using. Along with that, there is buck converter is there, SEPIC converters are there. It's play a very vital role because it ensures that electrical energy is correctly managed and utilized. The choice of the converter mainly depend on the specific requirement of the solar power installation at the time of installation, and the usage and application based wise the converters are using based on the size, configuration, then efficiency, how much efficiency the customer is required for the based on that reason the converters are mainly using. There are very so converters are mainly used for that voltage conversion and efficiency improvement, then battery charging purpose and system protection, and for the grid tied system also it is using. So now the how the integration of energy storage system with this system. So energy storage are the vital components. It is the key reason for why the energy storage system are using in the solar power system. That is energy supply consistently, then energy impedance reliability, then load shifting and peak shaving purpose, then integration with renewable energy, and grid services and support, economic benefits and environment impacts. The latest development of energy storage technologies in 2024 reflects significantly advancement and trends to aim to improving the efficiency, reducing cost, and enhancing sustainability, battery overproducing and pricing. Then government incentives and policies also started to introduce new energy technique and energy for the uses of energy storage system for the transport integration, electric vehicle infrastructure, and for the promote and recycle the reuse of energy. So waste energy management, optimize energy solution. For these reasons, these energy storage systems are mainly using day by day. It is mainly using then extreme weather conditions, short duration where it is required, and off-grid system. Then for the consumer adoption installer for this purpose, the energy storage system are using. For the battery backup system, then energy conversion, energy condition monitoring. For this, it is mainly using. Then I will tell that there is two, already I told that two systems are using. One is grid tied system and another is off-grid system. So generally for the residential, commercial, utility grid system, solar farms, urban areas, they are mainly that grid tied systems are using. And the advantages is these are the cost effective because there is no battery, there is no extra money is required for the battery or storage system. Excess energy can be sold back to the grid, providing financial benefit for also, and continuous power supply as the grid act as a backup system. Challenges is dependent on the grid stability, power outages, and regularity and policy changes, and related to net metering system and feed-in tariffs. If tariffs also somehow high, so that cases it will be not good. And off-grid systems, solar power system are independent of utility grid. They rely entirely on solar energy and battery storage system. Generally it is using for the remote areas and recreational areas, emergency area, or it is some for the short portable uses also it is using. Then it is complete energy independence, not affected the grid outages, sustainable and reliable power supply for remote locations, and smart charging system infrastructure, and battery resource utilization for demand response optimization purpose, and reduces the need of the this cost infrastructure, and promotes the renewable energy integration. For this reason, these whole systems are using. The challenges is higher initial cost. I already told there is a battery backup system, battery storage system. For that extra cost is required, and required for the planning and management, and ensure energy availability during low sunlight period. Limited for the battery. If the battery is going to off, then it is very difficult for the system to again its charging is required. That time that system cannot be used. So these disadvantages is there to facilitate this off-grid power system. So now I will
Any problem, ma'am?
no, actually it was not moving actually.
Yeah. It's moving now.
Okay. So now I will discuss about a case study. It is a paper-based work. I have taken one from one paper. It's a common paper. It's a They have done one case study with the Navi Mumbai area for their RRL lab, and it is calculating the irradiance of the solar power system. It's a rooftop system they are planning to install, and how much based on the government subsidy, how much cost saving they can possible, that is they have calculated, and how the power backup system they have done, it is they have calculated. Through the calculation they have proven it. So there is, they have mentioned they have a site, and the irradiance is defined as the average is isolation average daily, and it depends on the summer period, winter period, monsoon period. Different period the irradiance will vary. And based on the available rooftop area, they have used only 10 solar panels, and these 10 solar panels have 72 monocrystal cycle, and they have each crystal cycle have the 350 watt power, and the total plant capacity is 3.5 kilowatt. So 4.6 kilowatt dual MPPT inverter has been used here, and one 4-pole MCB is used at the substation for the circuit breaker purpose. And the proposed design, 10 panels use 350 watt nominal power rating, with 5 panels are connected in series, and 2 such strings are connected in parallels. So these are the electrical and mechanical data which I collected from the paper itself. The peak power, then maximum voltage, maximum current, then open circuit voltage, short circuit current, and efficiency. So the solar PV panel has been chosen based on the table of the electrical and mechanical data. Then irradiance will be calculated based on the irradiance level and the sunlight availability. So it is assumed that 9 hours daily the sunlight is getting. So during summer, average irradiance is 6.75 kilowatt hour per meter square. So they calculated irradiance, total irradiance is 750 watt per meter square. And the monsoon time it will be reduced somewhat, because all the time solar sunlight will be not available. In that case, it is coming under 530 watt 38 watt per meter square, and during winter it is coming somehow low, but not like monsoon period. It is 590 watt per meter square, and VMP and VOC are remaining same. They are also mentioning that 47.4 volt and 38.2 volt, and they have calculated that during summer period, if the irradiance is 750 watt per meter square and sunlight available, then it will be totally calculated. ISC value will come 7.32 ampere, and IMPP value will come 6.93 ampere. Then PNP is coming to 64.72 watt. So the total units is generated during the summer period for per panel, and power, the number of hours which the sunlight is available, the number of days. So they have counted 120 days, and total unit generation of the total power, then multiplied with the 8 hours sunlight availability and 128 days. So 254.18 units per panel units are generating. So total units generated during the summer, they have used 10 solar power panels. So it is coming to 541.8 units. Similarly, for monsoon also they calculated. For monsoon, it is coming to slightly low. It is coming 92.6, total units are coming 92.648 units per panel, and total units generated during monsoon, that is 926.48 units. And in winter it is coming for 7 hours. Suppose 7 hours the power, the sunlight is available, so they are also come lesser, little bit lesser than the summer. It is coming, total units is coming, generated is coming 178.91 units per panel, and total units are coming 1781.9 units. So if we adding all these things, it will come 5.249 megawatt hour per year, and total load consumption is 12.645 megawatt per year before. So they can save these 7.396 megawatt per year. Now, if we calculate the cost based on this calculation, solar panel, inverter, cabling, protection, structure, peripheral, and the design and installation for the unit cost and total cost are using. So it is coming under 246488 value, and the governments are giving them the subsidy in the 30% subsidy rate. So it is coming 73946. So based on the initial investment, total cost minus subsidy, it is coming 1,72,542. So cost per kilowatt, they can getting 49297.7 kilowatt, and the pay backup period is 3.008 years. So in this case, 3.5 kilowatt grid tied solar power system they are using, and after the power generation is calculating based on the initial investment and 30% subsidy rate they are getting. So they can reduce this after subsidy, they can reduce the money 1,72,742. And the cost per kilowatt for the system backup 49,297, and pay backup period they can calculate 3.13 year without subsidy and 2.91 years considering 30% subsidy rate. So these are the cost saving cost effective way if they install the grid tied solar power system instead of using the utility grids, normal grids they are using daily basis in the city. So this is one case study. Now I will move to the role of power electronics in the wind power application, because similarly for solar power application, the wind power application also, there are lots of applications are there. It is a very power electronics play a vital role in the wind power application. So enabling the efficient control generating system, double effect induction generator using for the wind turbine system, regulate the speed and torque and extract the maximum power point and for the wind energy. Then variable speed operation allows turbines to operate the variable speeds to optimize energy extraction under varying wind condition, reduces mechanical stress on turbine components exceeding their lifespan. Then power conditioning and conversion, AC to DC conversion, here also AC to DC and DC to AC conversion, converts variable frequency AC output from wind turbine system turbine generator into grid compatible fixed frequency AC power. DC link stages are using via rectifiers and inverters and ensure smooth and efficient power conversion for the power factor correction, enhances power factor to improve the quality of the power delivered to the grid. Then active filters are using here for advanced control technique, reduce the harmonics caused by switching in power converters, and grid inverters also using grid integration, voltage and frequency regulation purpose, ensuring that the power generated matches grid voltage and frequency requirements. Then reactive power compensator are using SVC, static power compensator, STATCOMs are using, and fall right to ensure the wind turbines can remain operational during grid application and complying with grid codes. Then maximum power point tracking also using here for the utility, using the extract the maximum energy from the wind under the varying speed. Then adjust the angle of the turbines blades to optimize the power output, the protect against overloading in high winds. Then battery management system, it enables the integration with energy storage again to store excess wind energy during low demand periods. In the high peak demand periods, so we can use this the excess energy which are using in the low demand period. That time we can substitute these things. And hybrid system is using facilities for the integration of wind energy with other renewable energy sources in hybrid configuration. Then over voltage and current protection protects generator and electrical system for the huge damages and transient condition from lightning and strikes and this system. Then surge suppression, they ensure safe operation for suppressing voltage spikes in the system and uses power electronics to safety despite excess during the high wind speed. Then reduce losses. Advanced semiconductor techniques are using components are using IGBT, MOSFET, SiC components to minimize the energy losses in the energy conversion process. And advanced control monitoring, turbine control system regulates generator speed, torque, and power flow using advanced power electronics, and support the offshore wind farms like high voltage DC, HVDC transmission system. Power electronics are enabling efficient long distance transmission of energy from offshore wind farms to onshore wind farms. And power electronics facilitates seamless integration of wind and solar energy system, optimizing the power generation. And filters are using to minimize the harmonics and ensure the power utility. Then benefits, mainly the benefits is conversion of energy, cost reduction, grid integration, variable speed operation, power quality, control and optimization, and protection system. Here I used a small block diagram of wind power system. Wind is flowing and it is connected with the wind generation system, and this is then coming the utility grid. Then there is another application is hydropower and biomass energy. There also this power electronics plays a vital role for the efficient power conversion, variable speed operation, grid integration, and stability. Then for the power quality improvement, dynamic control monitoring, energy storage integration, environment impact reduction, microgrids and off-grid application. So power electronics regulate the output of the hydropower generators like synchronous and asynchronous to ensure the efficient energy conversion, provide precise control of the generator speed and torque to match the turbine output with varying water flow condition, variable speed operation like allows turbines to operate at a varying speed, improving efficiency across a range of water flow rate. Then grid integration, AC to DC or DC to AC conversion, converts the variable frequency AC output from the turbine generated into grid compatible fixed frequency AC power. Then voltage and frequency regulation ensure power delivered to the grid matches required voltage and frequency standard. Here also STATCOM and SPC are using, and reduces the harmonic distortion for the power conversion process, improving power quality, control and monitoring techniques, the turbine control, then load management, then pump storage system and variable speed drives are using to adjust the speed and the drives. Then the microgrid and off-grid applications are also using, and there are energy storage systems are there, system monitoring for the harmonic integration, grid integration and fault tolerance and energy conversion also. So there are lots of applications are there in the hydropower and biomass energy for the power electronics application. And the total smart grid integration, if we tell the smart grid is the advanced electricity network with integrate digital communication, control system, renewable energy to everything will come. And it is the main motto is to optimize the energy production and distribution and consumption. So energy through the utility grid or grid stability or to the battery management system or the storage system, it's the main role to energy convert, energy store, and to minimize the loss, cost effective system, make the system mainly for cost effective. And for the system monitoring, real-time monitoring is very much essential. For that AI tool or machine learning technique can be used to monitor grid utility or monitoring system. Then it can integrate the whole renewable energy system, demand side management, then support for energy storage system, then bidirectional power flow. Then challenges what are the facing for the smart grid integration is high initial investment. There are lots of costs need to be bear for the customer side to install the smart grid in a system, and compatibility issues is also there for the new infrastructure, is heavy infrastructure. And the smart monitoring system what are they using for the off-grid system, there is a chances of cyber security risk or smart theft, that power theft issue can be facing. So these are the key things, key challenges in smart grid integration is seen. So previously now I move to the various application of the semiconductor based components that recently are using, and later future mainly these components will be used, because previously we are using various normal IGBTs, normal MOSFET and these things. But nowadays the key advanced semiconductor based techniques are using, and for the power electronics component for the improving efficiency, performance and scalability across a variety of application, including renewable energy also, electric vehicles application, industrial automation purpose. So these are have the high power, high efficiency application, and it are replacing the traditional silicon based devices. So there are devices are introduced like silicon carbide device, So SiC is a wide band gap material with superior thermal conductivity, higher efficiency, and greater power density than traditional silicon-based components. It is ideal for the high voltage application and high temperature and high frequency application, where the charging controller system, charge station, battery backup system, there this component can be used. And there are key SiC devices are SiC based MOSFET, that metal oxide semiconductor, field effect transistor. The application is high efficiency inverters, power conversion system in industrial application, where the advantages is low switching frequencies, switching losses, and higher operating temperature. The operating temperature range is very higher, nearly up to 200 degrees, where the extreme weather condition, if anyone can use the any devices and all, there this SiC based system can this MOSFET or IGBT can be used. And fast switching speed, and SiC Schottky diode also nowadays are using. So application is SiC MOSFET for efficient power conversion and high efficiency rectifiers, these are using. And compared, this is a fast enabling, compact, lightweight, and more reliable for the power systems. And these are things can be used. And for the power regulation, electric motor devices and industrial power supply benefits, that high voltage application like HVDC transmission and power grids, this can be used. Similarly for like SiC, there is another device is there, that is GaN, that is gallium nitride device. So that is for high electron mobility transistor application. This is using high efficiency power converter system like telecommunication radar, then aerospace application, then high switching frequency leading to smaller passive components like inductors, capacitor, reduce conduction losses for if we use for the GaN devices, low thermal resistance, and used in high frequency rectifiers and DC-DC converters, fast switching and low forward voltage drop, and enhance, and obviously efficiency will be enhanced. Wide bandgap semiconductor like SiC and GaN offer some substantial improvement also over traditional silicon based components. And high power density is their ability to operate higher voltage frequencies and temperature. Efficient power conversion also possible because of application of these components. And for inverter, motor drives, power converters, high voltage current handling, and high voltage and high current application, and power rectification purpose, these are the devices can be used. And there are some advanced IGBTs like high power application, industrial motor drives, high power renewable energy inverter, and super junction MOSFETs for the high efficiency in the medium power application, improved performance and at lower switching frequency. Then LED lighting system, electric vehicle charger purpose system, for these super junction MOSFET can be used. And there are some modular key integrated power modulars also. They are motor drive modular. They are used in electric motor drives, including for those industrial motor HVAC system, and efficient and design of the motor control. Integrated grid drives, solar power inverters, and UPS systems, and high efficiency systems. These are the things are using. So the key challenges facing in power electronics for smart energy system is high voltage and current stresses, thermal management, and harmonic distortion. There are lots of harmonic distortion when we deal with very high power systems, and harmonic mitigation is a part of these key challenge for the any module or any simulation or any applications. Need to mitigate this harmonic distortion. And intimacy of the renewable energy resources, complex control strategies. There are when we are using the advanced control technology, definitely the control technique will be the complex, so it will be not maybe friendly, and these things and initial cost is there, life cycle cost also there. These are the economic challenges for the power electronics when we use the advanced power electronics techniques in the smart energy system or the renewable energy application. Then compatibility with the legacy system, there are some policies also there. There are challenges are there, scalability is there. So for this also some legal issue can come. Then e-waste is also a challenge for the environment, and regularity standards and cyber security risk also there, power theft issue also there. So future we can use the advanced semiconductor materials like SiC, GaN, these things for the high power application, high voltage and current application, and the efficiency when the operating temperature range will be higher. Their extreme operating temperature, there these devices we can use, and hybrid renewable energy system, advanced grid support system, advanced energy storage solution, then enhanced control and monitoring system, increased uh, popularity, support things and new applications, you know, which are trains parts and the challenges people are facing when we are using for the application electronics, like harmonic distortion, lots of required, the filter purpose is required when you use the very complex model. There is filter issue, so time need filter these things, these harmonics, and efficiency for heat dissipation. For that the modern heat sinks, and we need to set all here. Then intimacy and variability and control complexity, and cost variability also for the challenges applications. So there are some solutions are there. Out such active filter issue. Additionally, we can design various modern converters, hybrid converter technologies, high quality multi-level converter topologies, or we can use some inverter, multi-level inverter technologies to reduce these issues, and implement advanced cooling techniques such as liquid cooling technology to manage this heat dissipation issue effectively. These high efficiency semiconductor device like SiC, GaN, this performance and efficiency and reduce the heat losses also. Then robust design practice, including the use of high quality materials like protective coating and systems. These are the robust design practice. Are the and any issue? Yeah. So, uh, are the key things, solutions we can provide, and overall summary I can conclusion like are critical in enhancing renewable energy systems and smart energy, divine efficiency and reliability, then in integration across various applications like energy efficiency conversion, like improved grid integration, power quality enhancement, uh, model control components like SiC GaN based components. They power optimize the techniques more, and the battery systems is more connected system to enhance the system, and the storage integration, and scale, make the robust system to make short form to oriented means home. It can be remote area also can be, and the environment benefit, and some issues also there that and future trends. So totally these things are come under the key challenges and key solutions of the critical enhancement of the renewable energy application systems and integration across various applications. So yeah, with this I can conclude my since
Here, you have heard a wonderful presentation on drives, importance of drives from the miniature to the maximum, and its case studies also you have heard. Faculty, if you have any doubts, you can ask the questions.
Madam.
One doubt.
Yeah, this is Professor V.V. Subbara. You said in our case study, Rajiv Gandhi, Gramin,
yeah.
You said we get 30 from yeah, this scheme present is an and what way it is different from the PM Suryagar project?
I think voice is cutting. Can you repeat once?
Yeah. RGG with Yojana, you said 30% subsidy is there from MNRE. And but Suryagar
actually this case study based, and they have implemented 2020. I will paper if you need. I have the link, and this particular for Navi. Yeah, it is the government subsidy is given by the India government. So that time it is using the 30% subsidy for the particular area for the rooftop system, using system. If they use for the challenges they can face, or the money they can save for the rooftop system if they use. These are the implementation of this case study. So what you are asking, that is means
still alive or not? First thing,
what
that scheme is still alive or not? And how it is differs from the PM Suryagar project presently?
See, that PM, I don't know about the PM Suryagar project recently. So this is particular this key project is alive or not. I will check and let you know.
Okay. And also you said the bidirectional motors.
Yes.
Present it is bidirectional.
Yeah, very directional converter using very rare case that boost converter in the in charging systems and all. But some cities using bidirectional converter because of the cost issues, and there are some government schemes there. Main industry focusing on this buck boost converter only.
But and another thing, the charge controllers also. But we are from mechanical engineering background, so that's why we do not know much about this. Gas.
No, that new technologies nowadays are replace the components like that SIC base all some companies like Lincoln and some companies like US companies introduce these SIC based gas based techniques because for the high application, and there are some extreme condition weather conditions. Generally the industry standard the components we are using -40 to 85 degrees centigrade, and the automotive standard it come 25. Suppose in the extreme summer area like Saudi Arabia, Dubai area, if they are condition and weather temperature is required, that time this SIC and GAN based is more useful.
And another one last point, ma'am.
Yeah.
That is backup energy. We have silicon carbide and as well as the gallium
Gallium
nitride
nitrate.
Semiconductors. Yeah, in recent times, this multi-junction so PV cells are coming.
Yeah, band gap techniques that for we need to check that, but generally this SIC and GAN based techniques, this component wide band. This can be there are some system is there. High performance application, these are mainly using high voltage application, high temperature range, these are using.
No, here multi-junction cells, the top layers will be with high energy, moderate energy. There, how we on what basis how we have to select?
Based on the application, if you need to check that if you need the only that top will be high and then medium energy, then low voltage, the component what are the operating temperature, what are the issues, the range, band wide range, then you need to check the voltage value, frequency value, value, all these based on the application, these are the need to choose components.
Okay, madam. Thank you very much. Now, the
One more question from my side, ma'am. You have explained economic analysis through your case study. In every system that we deliver to the public, what is the role of power drives which contributes to the net cost? How much net cost of the system diverted to the power drives of the system? Because you have done because drives also, you see, I am really surprised drives plays this much role in a system. So starting from miniature to the heavy hovercrafts.
Yes.
So cost.
See, suppose you are using various panels, solar panels, then the inverters. These are clusters coming for the solar power solar panels, and there are some inverters are cost and use areas hybrid inverters, then cost will be more. Use low power inverter like string inverter, then it will be lower cost. So based on that, cost will vary. So based on
will it be linked with the reliability of the system?
yes, reliability also can be checked.
Okay. Faculty participants, we have come to the end of the second session on electronics drives in the applications of energy sector. Renewable. Is friends, do you have any doubts? You can ask, or otherwise you ask. You can write in the chat box also. You can ask through chat. Any doubts? Okay, madam. Nice presentation, and we love to be associate with you in future. Our requirement, because we have power electronics and drive MTech power electronics and drive, and we are planning to integration of thermal with these students. We have mechanical engineering, thermal engineering, power electronics and drive. So if our need any support from yourself, because you are just working in industry,
Yes.
what sort of help that you can extend to our and dive students, ma'am?
See, there are two courses are there. There is one internship for the PG level and graduation level also there. The interns, they doing that 11 months internship
There
course.
are few students have joined this presentation because of this power electronics subject. Can you brief on projects that you undertake and what their future prospectus power electronics subject?
Yes, there are lots of prospects are there in power electronics and drives. Nowadays, we use the AI techniques and machine learning techniques, and in the power electronics application, it will be very helpful for future aspirants. And in our in our company, there is one sector is there totally robotic and automation department. They are using modern robotics based controller technologies, and these things they are handling the robotic machines also for the welding application. Companies mainly welding application. There are lots of applications are there. The medical applications also there. So in that case, there are lots of prospects and futures are there uh, in the power drives, and it's totally there are so many industries there. Not industries are there like ABB is there, Schneider is there. They are working with voltage and drives actually. So in this application, there is a good prospects. And
one more question from participant. Which semiconductor switch should be used for semiconductor switch? They are asking.
yes, I saw the question. Yes, sorry, we can use the semiconductor switch. That also depend on the application, sir. Based on the application, we can use for EV. We can use PWM controller technology. Vector control is using mainly for the motor controller technology for the high power applications and all. EV mainly PWM controller technology, or if we use the solar power plant and solar panel, the MPPT controller technologies are using. Vector control technologies is using in pump application, and the motor controller technology we can use.
participants? Any other doubts? If no one is having doubts, so we'll turn on our videos. Please turn on once. If the participant have a specific doubts, you can write in the chat also. Thank you. Thank you very much. Have a nice day. And tomorrow, our